Good morning, everyone. This is Mark with Wear Parts, and we have next to me today our veteran professional tillage customer care guy, Eric Derry. And what we want to talk about today is twisted chisels and the beaver tail shovel. Tell us a little bit about the application of these, Eric.
This is a chisel plow application, so it's going to go on a standard chisel plow shank. It's going to have the 2¼ inch centers. And the twisted chisels are going to be if you're wanting to throw that dirt up to the side, off to the side. So it's like almost like a mini plowshare, kind of. You're actually moving that dirt from one side, flipping it over, just kind of getting it out of the way. So these work great for that. You can see they've got the got that little bit of a twist to them. So as they're bolted on, this is going to be sitting flat. It's going to be cutting through here. And that soil is going to travel up
And throw. Okay, so yeah, tell us, how do you tell a right hand from a left hand on those twisted chisels?
Well, when you're standing behind the machine,
Okay,
it's going to be the direction that the dirt goes.
gotcha.
So if you're looking at, on this one, this would be a left hand, so it's coming up and the dirt's going off to the left.
And this one here is bolted on there, so it's coming up and it's thrown to the right.
Correct.
And then do you have to actually get the same amount of lefts and rights on a machine?
Yeah, if you have an odd number of shanks, you're going to be one off, but
Gotcha.
you're going to even that up as much as possible.
But you can't run all rights on a machine.
No, you'd end up dog tracking right through the field.
Very good. All right, and we offer hard facing on the twisted chisels. Have we ever hard faced these? Do you know?
I don't know that we actually have, but there's no reason that we couldn't.
On the beaver tail shovel. And that's using our cold metal transfer process, CMT process. Tell us a little bit about that process.
Well, on a cold metal transfer, you're putting less heat into it than any other hard facing application, whether it be oxyacetylene or standard hard facing. That heat input is low enough that it's going to gain you quite a few things. You're not going to have the dilution of the material. The material is going to stay on top. That hard material is going to stay hard. That base material is going to stay where it's at. So they're not going to be melding together. You're not going to have any cracking because the heat input is not enough where you're going to have those different cooling rates, those extreme different rates between the two types of metal that could cause cracking as they cool off. And the other thing too with that is that you're not going to have any change in the temper of that base material because of the cold metal transfer. It's low enough. It's not hitting that transformation temperature. That's going to change the temper of that steel. If it starts out at a 48 to 52 Rockwell, like what all of our base material does, it's going to stay at that.
That's a good point. So all of our base material is high quality tempered boron steel, tempered to 48 to 52 Rockwell. And then when we use that cold metal transfer process on top of it, it doesn't pull that temper out of the base material. And that CMT hard facing, that ends up in the the high 50s, low 60s for HRC. So you're adding roughly 10 Rockwell on the edges of these parts. So what that gets you, what that gets the farmer is a longer wear life, reduced downtime, and ultimately a lower cost per acre. So it's a win-win situation for the end users on this Wear Parts product. Well, that wraps it up today. From Gothenburg, thank you.